Hey, hello there. So in this video, we are going to discuss about the next set of bitwise operator, and they are bitwise and bitwise OR and bitwise XOR operator. Okay. Now for this video, I'm assuming that you have basic electronics knowledge, right? So usually when you go to your 11th, 12th grade, usually you have electronics in your course, or usually when you go to engineering, then you have a basic electronics in your course. Now even if you don't have electronics in your course, then actually let me just tell you a brief idea about how these operators are actually built up and what is the basic intention behind having these operators. Okay, so actually in electronics we have certain kind of gates. So we have AND gate, we have OR gate, and then we have XOR gate. Now the gate is nothing but a device and which takes two input, or it basically takes some input, and then depending on what inputs you are giving it, it will give you an output. Okay, so this bitwise AND operator in C++ is actually created on the base of, or it is basically taking motivation from AND gate of electronics. Similarly, this OR operator, bitwise OR operator, takes motivation from OR gate of electronics, and this XOR similarly is taking inspiration from XOR gate of electronics. Okay, so in electronics we can have multiple kind of gates. We even have more different types of gates in electronics, but in C++ programming we just have three operators which basically kind of support them, right? So we have AND, then we have OR, and then we have XOR. Okay, in electronics we have truth tables of these gates, right? So let's quickly see the truth tables just for a revision purpose, and then by that we will just understand how actually these operator works. Let's see how the AND operator works, or let's see the truth table for AND operator. So the operator is AND. It is written like this using AND symbol. Then this operator is a binary operator. Again, it is a binary operator, right? Now it is going to take two inputs as it is binary. Let me write first input, that let's say OP1, that is operand 1, and let's say the second input is, let's say, operand 2, and then we have result. So we have two operands, operand 1 and operand 2, and then we have result. Okay, now let's quickly see what can be the possible operands, as it is a binary system. So let's say we have first operand as 0 and second operand as 0. We can have first operand as 1 and second operand as 0. We can have first operand as 0 and second operand as 1, and then we can have first operand as 1 and second operand as 1. So these are the four possible combination if we have two operands. Now in case of AND operator, the output is going to be 1 if all the operands are 1, otherwise it is going to be 0. It's very easy, right? So in this case the output or the result is going to be 1 when both the operands are 1. So in this case both the operands are 1, that's why the result is 1, otherwise it is going to be 0 0 0. Okay, so this is how the AND operator is going to work. Let's see how the OR operator is going to work. In case of OR operator, the truth table looks something like this. So we have operand 1, similarly we have operand 2, and then we have, let's say, result. Okay, we'll have same set of operands, right? So it is going to be either 0 0 or 1 0, or it is going to be 0 1, or it is going to be 1 1. Now in case of OR operator, the answer is going to be 0 if both the bits are 0, otherwise it is going to be 1. Okay, so the answer is going to be 0 if both the operands are 0, otherwise the answer is going to be 1. So in this case, not both the operands are 0, that's why the answer is 1. Here also not both the operands are 0, one of them is 1, that's why the answer is 1. In the last case as well, both the operands are not 0, both are 1, that's why the answer is 1. So in case of OR operator, if any one of the operand is 1, the answer is going to be 1. In case of AND operator, if both the operands are 1, then the answer is going to be 1, otherwise it is going to be 0. Okay, actually it basically works very similar to your logical AND and OR operator. In case of logical AND, just try to remember, if the both expression or both the sub expression or both the operands are true, then the output was true, otherwise the output was false. Similarly, in case of logical OR operator, if any one of the operand is true, the output was true, otherwise the output was false. Okay, so actually this also works very similar. In this case, the output is not true, false, it is 0, 1. Okay, and let's quickly see the truth table for the last operator that we have in bitwise category, that is bitwise XOR operator. Okay, so we have operand 1, we have operand 2, OP2, and then we have result, right? Okay, let's quickly write operand 1 and operand 2. So 0, 0, then we can have 1, 0. Actually it's same, I'm just repeating it just for your understanding. Then we can have 0, 1, and finally we can have 1, 1. Okay, now in case of XOR, this XOR is actually kind of interesting. It's kind of little bit different from AND and OR operator. In case of XOR, the output is going to be 1 if any one of the operand is 1, otherwise it is going to be 0. See, output will be 1 if any one of them is 1, otherwise it is going to be 0. So in this case, not a single operand is 1, that's why the output is going to be 1. In this case, one operand, that is operand 1 is 1, that's why the output is going to be 1. In this case, operand 2 is 1, so output is going to be 1. In this case, both the operands are 1, but what this operator wants, it wants just single operand from them is to be 1, not both of them. So that's why in this case the output is going to be 0. Okay, so I hope now you have got a basic idea about how the XOR operator works. So XOR operator needs only one input out of two inputs to be 1. Okay, if both the inputs are 0, then the answer is going to be 0. If both the inputs are 1, then also the answer is going to be 0. But if one of the input is 1 and another input is 0, then in that case the output is going to be 1. Alright, so in this way basically the XOR operator works. Alright, now let's quickly see some examples and let's try to apply this bitwise and bitwise OR and bitwise XOR operators on them and just try to find out the outputs or just try to find out the answers. Alright, so let me just quickly clear the canvas. Let's consider two operands, right? So we need basically two operands because all these three operators are binary operators. So let me just consider the first operand. Let me write it as operand 1, and let's consider the second operand. Let me write it as operand 2. Okay, let's consider the first operand is, let's say, 3 in binary. Okay, and let's say not in binary. Let's consider the first operand, let's say it is 3 in decimal, and let's say the second operand that we have is, let's say, 2 in decimal. Okay, now let's quickly convert them to binary because again they are bitwise operators, so we need to do everything, every calculation that we do will happen in binary. Alright, so let's quickly convert them to binary. So we know 3 can be converted to binary and it will be something like 0, 0, 1, 1. Okay, when we will convert 2 to the binary, it is going to be 0, 0, 1, 0. Alright, now let's apply AND operator on them. Okay, so if I want to perform AND operation of 3 and 2, the expression will look something like this. Okay, so if I write 3 and 2, always remember in case of bitwise AND operator we have single AND, not double AND. Double AND basically means logical AND operator. Bitwise AND, in bitwise AND case we have to write a single AND operator, right? So when I will write 3 and 2, basically we mean 3 we are doing bitwise AND with 2. Okay, now let's see how it will work. So 3 in binary, let me just write it in this format. 3 in binary is 0, 0, 1, 1. We are doing AND of this with 2, so 2 is nothing but 0, 0, 1, 0. Okay, let's quickly find out what is the output. See, we have to write or we have to perform AND operation on individual bits. Okay, so what is 1 and 1? What is 1 and 0? 1 and 0 is 0. See, the answer is going to be 1 only if both the operands are 1 or both the bits are 1. If any one of them is 0 or both of them are 0, then answer is going to be 0. What is 1 and 1? 1 and 1 is 1 because both of them are 1, then it is 0 and then it is 0. So what is the output of 3 and 2? Output of 3 and 2, if we will convert it back to the decimal, is nothing but 2. Now let's see the same example for the bitwise OR operator. Okay, so let me write it again. So it is 0 0 1 1 or 0 0 1 0. Let's see what is going to be the output of this. See, 1 or 0, what is the output? It is going to be 1. 1 or 1, it is again going to be 1. 0 or 0, it is going to be 0, and then again it is going to be 0. So the output, if you will convert it back to the decimal, it is nothing but 0 0 1 1, it is nothing but 3. Okay, so this is the output when you will perform 3 or 2. Okay, so let me just write it on top of it. So this operation is nothing but 3 or 2. Okay, it is an OR operation. Similarly, let's perform 3 XOR 2. Say, okay, so it is 0 0 1 1, this is 3. Then we have to perform XOR operation on it, and the second operand is 0 0 1 0. Okay, let's see what is the output. See, 1 XOR 0 is going to be 1, because not both the operands are 1. One operand of them is 1, so that's why the answer is going to be 1. Then 1 XOR 1 is going to be 0, 0 XOR 0 is going to be 0, then again 0 XOR 0 is going to be 0. So the output that we are getting in this case is nothing but 1. Okay, so the answer of 3 XOR 2 is nothing but 1. Quite easy, very easy. You just have to remember those truth tables. If you remember those truth tables, you can easily calculate answer of the any question, or you can easily calculate the answer of any expression, I will say, right? Now you may expect such kind of questions in your MCQ test. That's why it is very essential to have a basic knowledge about how you can convert any number to binary, then how you can apply any operator from bitwise category, from I will say from this set, that is AND, bitwise OR, bitwise XOR.